All right, section 4, greatest common factor. Let's go. All right, so we get to start with our Venn diagram. I had a really fancy picture of some old guy, but I don't know if it's actually the guy or not. Okay, so if you came up with the prime factors of 12, so I do my primes here. Whoops. Where did my... For some reason my pen is not working, so let's go down here instead. 12, I would have 3, and then 2, and 2. The prime factor of 20. 20 is going to be 2 and 10, which is going to be 2 and 5. So which of these numbers are in both circles? So 3 would be, whoops, I need to change my color here. Make it a readable color. So over here is going to be 12. Over here is going to be 20. So I'd have 3 here, 5 here, and then they'd share the number 2. Because there's 2, 2. 3 goes here, 2, 2. 5 goes here, 2, 2. So find the product of the ones that are inside both circles. 2 times 2 is going to equal 4. Ugh, I hate it when it does that. Is the product both also a factor of 12 and 20? So 4 is a factor of 12, 3 times 4, and 20 would be 5 times 4. So yes, it would be. So then you can make a diagram, and we'll skip that step there. So you can make a Venn diagram of other numbers as well if necessary. So what we're working on today is the greatest common factor. The greatest common factor here was the number 4, because those are the two that were in the middle of the Venn diagram. So greatest common factor, numbers that have some of the same factors, the greatest number of that factor of 2 or more numbers. So that's why I say if it ends up being 2 times 2, it could be multiple ones together to make the greatest common factor. Usually you'll end up listing them all out. All right, so find the greatest common factor of 16 and 24. So there's a couple of methods here. I'm going to show you them both. So method 1 is list all the factors out. So for 16, if you did your factor tree, it'd be 1, 2, 4, 8, 16. For 24, it would be 24. 1, 2, 3, 4, 6, 8, 12, 24. So we've highlighted in yellow the ones they have in common. So the biggest one that they have in common is 8. So the greatest common factor, as in things that can be multiplied by something else, would be 8. So the other thing we can do is actually straight up prime factor them like we did yesterday. So 16 would be 4 2s. 24 would be 2 times 2 times 3. Now we can combine together the ones that that all together go together and then multiply those 3. So the greatest common factor is the product of the common prime factors. So multiply those together would be 8. So the same answer. All right, so choose your method and try it. Go. All right, so I'm going to do kind of both, I guess. So if I took 18, I can go 1 and 18. It can divide by 2, so it's going to be 2 and 9, 3 and 6, 3 and 6. So there's all my numbers there. 30 would be 1 and 30. 2 and 15, 3 and 10, 4, nope, 4, 5, 5 and 6. There we go. So the common one would be 6. So I think my greatest common factor is going to be 6. Find the greatest common factor of 28 and 35. Okay, so first we'll factor each number completely out. So 2 times 2 times 7, and 5 and 7. The common one they have is 7, so the common prime factor is 7. Find the greatest common factor of 12, 48, and 72. So first we're going to factor each one out. 2 times 2 times 3. 48 would be 4 2s and 3. 72 would be 3 2s and 3 3s. Notice here that they lined them all up. That's huge, because if you put these 3s here, you'll get them confused with, or it's easy to get them confused. So having extra space in between each one is really key so that they line up. Okay, so the 2s they have in common, 3s they have in, are 2, 2, and 3. So I'm going to multiply those 3 out. 2 times 2 times 3 is 12. Another way on that one, you could have just looked at the original number. 12 divides into there, 12 divides into there. That would have worked too. As I say, there's multiple ways to come up with these. Figure out the method that works best for you. All right, find the greatest common factor of each of these. Go. All right, so let's try these out. 24 and 30. So 24, we could be 1 and 24, 2 and 12, 2 and 12, 3, and, oh, come on. 8, and then 4 and 6. All right, so lots of them there. So 1 and 32, 2 and 16, 2 and 16, 3 and 32. I'm just having a hard time here. Nope, 3 doesn't go in there. 4, oh yeah. 4 and 8. 5, nope. 6, no. All right, so those would be the ones. So the biggest common one they have is 8. All right, so this other one I'm going to do the other way. So I'm going to take 30. That's going to be 2 and 15. It's going to be 3 and 5. 42. It's going to be 2 and 21. Which is going to be 3 and 7. 60. It's going to be 2 and 30. It's going to be 2 and 15, which is 3 and 5. So I can list them all out here. Let's go 30. It's going to be 2 times 3 times 5. 42 is going to be 2 and 3 and 7. 60 is going to be 2 times 2 times 3 times 5. So we have this one in common, this one in common, this one in common. So 2 times 3 is 6 times 3 is, or times 5, so 2 times 3 times 5 is 30. I feel like I did that wrong. Yep. Oh, yeah, because this one's not here. 2 times 3, so 6. There's only 2 of them here, not 3. All right, so you might see something like this. Parents donated 150 chocolate chip cookies and 120 molasses cookies for the bake sale. If the cookies are arranged on plates, each place has to have the same number of cookies because it looks pretty like that. With the same number of molasses cookies and the same number of chocolate chip cookies. What is the largest number of plates possible? All right, so the greatest common factor of 150 and 120 is what we need to do. So 150, when we factor that out, goes to 2 times 3 times 5 times 5. 120 is 2 times 2 times 3 times 5. Common factors are 2, 3, and 5. So the prime factorization of that is going to be 2, 3, and 5. Put those together, that would be 30. So there are 30 plates possible. All right, so parents donated that. So how many chips and collected cookies will be on each plate? So we take 150 divided by 30. So there's going to be 5 cookies, or 5 of one type and 4 of the other. So each plate will have 5 chocolate chip and 4 molasses. And I'm going to skip this one for time. All right, find the greatest common factor of these two. So we have to come up with the factor. First, we need to completely factor each one. So I'd have to do the factor tree for 18, the factor tree for 42 to get these out. Notice we lined them all up there as best we could. So circle the common factors. So the greatest common factor of this is going to be 2 times 3. So I can put those together and make it 6. And then 1x and 2y's. All right, pause this, give it a shot. All right, so you're going to have to prime factor them out first. So let's do 32. It's going to be 2 and 16. And that's going to be 2 times 2 times 2. Let's do 80. 2 and 40, which is going to be 4 and 10, which is going to be 2 and 2, which is going to be another 2 and a 5. So we can write these out over here. 32 is going to be 2 times 2 times 2 times 2. And then 80 it's going to be 1, 2, 3, 4. 1, 2, 3, 4, and then a 5. All right, then 1m for 32 and 4 n's. Figure these are going to run into each other. I think technically I do have an eraser here. Then I have 3 m's and 2 n's. So I have an n, 1 m, and then 4 of these. So my greatest common factor is going to be 2 times 2 is going to be 16 m and n squared. See if we did it right. Hey, I like it. Okay, so factor this out. So first we need to find the greatest common factor of 3x and 12. So 3x would be 3 and x, 12 would be 2 times 2 times 3. 3 is the only one we have, so the greatest common factor is 3. So then we can now divide each one, now write each product term as a product of the greatest common factor and its remaining factors. So we pull 3 out of both sides, and then we'll group it with 3 and x plus 4. This is really a long way of doing it. It's great, but eventually you just look at this and go 3 divided by 12. 3 goes into 12. I can take 3 out of this and 3 out of this. It's where eventually you get to. All right, pause this, give it a shot. All right, so there's 2 ways to do this. The long way, which is fine. The way the book wants us to do and what work I want to see you do is you're going to factor out 4 goes to 2 times 2 and times x, and then 20 goes to 2 times 10, which will be 2 and 5. So they're going to want you to go 2 times 2 and a 5. The common ones are here, so I can pull 4 out of both. So I could actually say divide this by 4, divide this by 4. This goes to 1. I'm going to jump down here because the answer is going to be right here. So I'd have 4 times x plus 4 times 5. So then I can do a 4x plus 5. See, what I would have just done is I looked at this and go, 4 can divide into 20, so I can take 4 out of there, divide both sides by 4, and then it comes out to that. That's what I think. Whichever method works for you, do so.